Hello, everyone. Welcome to the next in our series of webinars in the Sustainable Cereals International Student Competition. I'd like to welcome everyone back from the winter holidays and wish all of you a wonderful 2020. Hope it's off to an excellent start and that continues today with our student suggestion webinar. All of the teams submitted suggestions and they were excellent, and we made a big table with all of your ideas, and we found some fabulous experts to give presentations on the ideas that were the most common. So I remind you about using the webinar system because these presentations will be interactive as much as possible. And the presenters will ask you questions and ask your opinion, and we will open your microphones. So you all see this control panel, and you see that the red arrow lets you minimize the panel so it doesn't cover the presenter's slides. You may or may not be able to control your microphone, but we will control it for you. And you can raise your hand. You see the hand icon, and we will then open your microphone and let you talk. As always, this session is being recorded, and it will be available on the ISEKI-Food YouTube site. And we will ask the presenters to also make their slides available for all of you. So our agenda today is the following. We have 4 experts in cereal science, and they will each give approximately 15-minute presentation, which includes the time for interaction. So, and then at the end of our session today, Lina and I will briefly review with you what is coming up in terms of the schedule for the Sustainable Cereals competition. So stay tuned for the entire webinar. And we will take your questions at the end about any technical points or logistical points about the competition. So today, we start with Denise Bender, and she is a postdoc at the University of Natural Resources and Life Sciences in Vienna. And she will talk to us today about improving gluten-free bread by novel arabinoxylan networks. So I turn it over now to Denise. Okay. Denise, you are presenter.
Thank you. Welcome everyone to my presentation. So what I will talk about, I will give you a short overview of what are the problems in gluten-free bread during the production of gluten-free bread, and how we as POCO, as our university, are overcoming these problems. So as you can see, there is a huge gap between quality between gluten-free and gluten-containing breads. It's still visible. Everyone that has tried gluten-free bread, you can compare it with a gluten-containing bread. And this is because gluten is responsible for the high baking quality and the viscoelastic properties of the dough. When it comes to gluten-free, well, the gluten itself is missing, and therefore there are several issues that arise due to that. For example, gluten-free breads are normally characterized for their poor nutritional value. This is because they are made out of normally a lot of starches, they lack protein, they lack dietary fiber, and it comes sometimes to nutrient deficiencies in the consumers. As for technological properties, well, since the gluten is absent, the dough, which you cannot call a dough, it's rather a batter, because it's very, very liquid. It resembles a cake batter. It's poor in viscoelasticity, and the breads are usually low in volume, firm in the crumb, and they stale really fast. And as well, the sensory properties are lacking. There are a lot of issues in there. When it comes to ingredients, we can see on the bottom slide, there are 5 ingredients when we talk about gluten-containing bread. And gluten-containing bread, the most common bread is wheat bread. So we have flour, salt, sugar, yeast, and water. And the stability of this dough is mainly controlled by the gluten. In case of gluten-free bread, since gluten is missing, this is mainly controlled by the starch. So my question to you is, if you know which ingredients are necessary or how many are necessary for formulating a gluten-free bread, how many ingredients do you think that need to replace the functionality of this single molecule of gluten?
Okay, the students, this is a question for you. So please raise your hand and I will open your microphone. So how many ingredients are needed to replace gluten? Right, Denise?
Exactly.
So, yeah. Don't be shy. Somebody must be brave enough to.
So
We have
okay.
Maria, I can open your microphone.
Yes, good morning. Do you hear me?
Good morning.
Yes, so thank you for the opportunity of participating. Well, for gluten-free bread, it will be needed much more ingredients like stabilizers, gelatinizers, starches, and also maybe some proteins to make an equilibrium with the gluten that we are not forming, and also maybe use some flavorings.
All right, you did say a lot of right ingredients. Does anyone want to complement that? Does anyone think that there's something missing that Maria did not say?
Don't be shy. Someone else can please add to our discussion. What else do we need to make a gluten-free bread?
All right, I will tell this for you. Okay, so what we need is at least double as much ingredients as in wheat bread. And we have the same 5 ingredients that we use for wheat bread. So we have a flour, of course, gluten-free. We have salt, sugar, and yeast. We have double as much water as the conventional wheat bread because we have a lot of starches. So the starches need to gelatinize. They absorb a lot of water during gelatinization. That's why you need double as much. You need starch sources. You also need isolated protein because you have to substitute the gluten network to some kind of protein. You need fats. You also need emulsifier for stabilizing the bread, the dough, and hydrocolloids for thickening the dough. And of course, these are a lot of additives or ingredients, and sometimes sourdough is also used. So sourdough can be used to substitute a lot of additives or ingredients because it does not only enhance the technological properties of the dough, of the bread, but also the flavor and also the nutritional properties. All right, we saw the list of ingredients, and research so far has shown that no baking additive has been fully able to match the performance of gluten. It is not substitutable. We at the BOKU, at the university, we are trying to find alternatives. And one of the alternatives that we found was to imitate a rye bread-like structure. Rye is quite interesting. If we think about the best bread that we have, it's a wheat bread. Rye, on the other hand, has also a very good quality. But rye has a lower gluten content. It has around half as much gluten content. The quality of the gluten is much lower. So the baking ability itself is not entirely attributed to the gluten present, but to other components, which are arabinoxylans. These arabinoxylans, we will come to that, what they are, what they do. They cross-link, they form a network similar to the network that gluten forms in a gluten-containing bread. But in order to form this network, they need to have a low pH. And that's why always rye bread is always done with sourdough. You won't find any rye bread that hasn't been done with sourdough. This is crucial for the baking quality. So if we come to arabinoxylans, another open question for you. Do you know what arabinoxylans are? To what group, nutrient group do they belong to?
Okay, we are looking for a hand to be raised. Someone will surely take a guess.
Is it maybe a fat? Is it a protein? What is it?
Oh, I see a hand, Maria. Maria, your microphone is open.
Hello.
Hello.
Yeah, so arabinoxylans is categorized as starch, is carbohydrate, but is categorized as hemicellulose.
Yes.
Mm-hmm.
So in other words, they are fibers, hemicelluloses. Where are they found? They are found in the outer layer, in the bran, and in the endosperm cell walls of the cereals. And since they are a dietary fiber, they absorb water in the dough when you're baking a bread, and they're forming also a carbohydrate network, a hemicellulose network. And this happens quite naturally in rye bread. So we thought, okay, if it happens naturally in rye bread and it functions quite well, if we're able to isolate these arabinoxylans and add them to a gluten-free bread, maybe we can also enhance the quality of gluten-free bread. And of course, the nutritional value, because we are adding fiber as well. So what we did overall was to extract these arabinoxylans from a very cheap byproduct of the cereal industry with a relatively environmentally friendly alternative. So what we did, we used different kinds of solvents. We used water, alkaline solvents. We used enzymes to extract them. We mixed those two procedures. And after all, we had different types of isolates. We varied the extraction conditions and created different isolates to see how the extraction will modify the structure of our arabinoxylan and of course also the functionality. But before adding them to our bread, we needed to set the pH of our dough. That's where the sourdough comes in play. So for that, the problem with sourdough in gluten-free products is that there are not a lot of commercial available products. There are not a lot of commercial available starter cultures, and not all starter cultures can be used with all gluten-free materials. So we tried 7 different isolated lactic acid bacteria, 1 commercial starter culture, and we added it to our bread. In this case, we used a buckwheat bread. And you can see already in the pictures that the different type of lactic acid bacteria influence differently the properties of the bread. And the ones that are highlighted in green were the ones that worked the best. What we also characterized was not only the bread itself, but also the sourdough. So you can see on the graph the pH of the sourdough, of the bread dough before fermentation and after fermentation. And we saw that it varied a lot with the lactic acid bacteria. This is very important, not only for the arabinoxylans, but also they affect the texture of the bread, the pH, but also the type of acids. and the ratio between acids affects extremely the softness of the bread. So we had to take into account that. And after selecting the sourdough, the appropriate sourdough, what we did was used a formulation with the least additives possible. And we added also the arabinoxylans for that. And you can see we have 7 different arabinoxylans extracted in a different way with either solvents or enzymes. And you can see that really the extraction of the arabinoxylan does have an influence on the properties of the bread, especially for the specific volume. But overall, what we can see is that each arabinoxylan that we used enhanced the properties of the bread, except for one. Also, for the specific volume, also for the firmness, the crumb firmness. And what we took from that is that it's very important to take into account the arabinoxylan properties. So when we are extracting it, we are modifying the properties. So it's very important to have this balanced extraction conditions to get a high qualitative bread. And of course, all the flour properties as well. So the arabinoxylans that work with this buckwheat bread did not work the best with other flours. We tried also other breads with other flours. So for each one, we had to optimize this. And so I come to my conclusion. So what we learned with this was that extraction is quite important for defining the functionality of our polymer, of our arabinoxylan. We also saw that the sourdough, it's very important to select a specific strain that is compatible with our flour, because this will also influence our quality. And overall, what we saw is that arabinoxylans are quite suited for adding them. This can be used as natural structure forming agents for gluten-free bread. Of course, how much these arabinoxylans will improve the bread will depend, of course, on the properties of these same arabinoxylans. With that, I would like to thank you, and if you have any questions, please feel free to ask.
Thank you, Denise. Thank you very much. That was excellent presentation, very clear, very interesting. So Lena and I are looking at the list of attendees, and we invite questions and comments. Please raise your hand. Oh, Maria. Maria, your microphone is open.
Hello, Denise. I want to with the pictures.
Sorry, I didn't get that. The connection was bad.
I would like to see the picture from previous slide.
On the previous slide, of course.
Yeah. There is a picture of H2O and pentopan.
Yes.
Can you explain why it's quite different with other breads? Because
yes, normally what we saw with this pentopan is the enzyme that we use to extract the arabinoxylan. So we used, in this case, a water extraction combined with an enzymatic extraction. This we used there, it was like 2 extractions in one step, and this to enhance the yield of the extracted arabinoxylans. And this worked the best because water extractions are less damaging the structure of the arabinoxylan. We also had some alkaline solvents that damaged this arabinoxylan, and that's why the water with pentopan increased the properties as most, because it's a process that did have little yield, but damaged the polymer the least.
Damage the polymer least, so it at the end you will have more Arabo,
Arabinoxylane. Yeah, it's a tough word.
Wow.
Yeah. Yeah.
Is it improving the gelatinization process as well?
It's, of course, it's affecting the gelatinization of starch because dietary fibers are absorbing water, but since what we took into account was that each arabinoxylane absorbed different amounts of water, and therefore we added a little bit more water for those that absorbed more water, so that the gelatinization in each bread was the same, or the water available for gelatinization in each bread was the same.
Okay, thank you.
Thank you, Maria, for very good questions. And we have a couple of more minutes and invite some of the other students to make a question or comment to Denise.
Bagus habis. Gitu ya.
Do you see anyone else, Lina?
No, I don't
No.
think we have any more questions. So
Me neither. Okay. Okay. Denise, I would like to ask you about the taste of the different breads that we see here. You said early on that the sensory properties were not appealing to consumers. Was there a consumer panel here for the taste?
No, was actually just a fundamental research. We didn't take into account the sensory properties. Of course, we tasted them, but there's still a lot to do. I mean, sourdough helps a lot in improving the taste, but there's still a lot to do for that.
Okay, great. Okay, thank you, Denise. So we move on in our series of short presentations, and we go now to Gerhard Schleining. And Gerhard is a professor at the University of Natural Resources and Life Sciences in Vienna. And he is also the Secretary General of the ISEKI-Food Association. And Gerhard will talk to us now about experimental design. And Gerhard, you are presenter, so go ahead.
Okay, thank you very much. Do you see my screen? I think yes, sir. Do you see the presentation? Yeah.
yes, we see it.
Okay. So there was the request of a team. The team applied to give some information on how to use experimental design for their research. And in this short presentation, I would like to give you some examples and how these or some of these designs can be used for your research. And then the idea is that maybe you have some applications in mind. We can discuss these applications more in detail, what kind of experiments you can use for that. So there are many objectives which can be solved with this design of experiments. You have also already seen in the presentation before, there are many factors which can affect the quality of products like bread, and some ingredients or some other factors for the processing may be significant, and some of them are not. So this is the use of these designs is one way which is very efficient to find out which factors are significant. The second objective for what you can use this tool is to quantify the effects of maybe one ingredient or processing parameter like the fermentation time or whatever. And what is also very important is you can find out interactions, because also in the last presentation you have seen there may be some interactions between different ingredients. So they may affect each other in a certain way, and with this tool you can find out how they are interacting. And another objective could be that if you have found with this tool a model, so you can predict or pre-calculate a quality characteristic of a product, you can find out the best factors, how you can combine them to get the same product. But we will come to that later. Many researchers use design the experiments so they keep everything constant, and then they change one factor and find out what is the best result. And then when they have found out the best result, they will keep this factor constant, and then they will change the other factor and find out how the response is improved. This is a way which is in many cases not sufficient to find the real optimum, and in many times you need a lot of experiments. And with this tool, the design of experiments, you can find out a model which is very useful, and you need not so many experiments to get to these results, but I will come to this later. There are different types of designs you can use. I will only focus on these factorial designs. This is a tool where you change a factor on two levels, and you combine these in a plan. In some cases, for example, in the serial research, you have a lot of factors, and it can also be used to find out the significant factors. The disadvantage of these factorial designs is of the first order designs is that you can only describe relationships which are linear. That means if you increase the concentration of one ingredient, there must be a linear relationship like this, or in the other case of the other ingredients, so it's decreasing when you increase the concentration. But in many systems, these relationships are not linear. So for example, you have an optimum somewhere in the concentration, and to describe this model, you have to use second order models. Another type of designs are mixture designs, especially in this area where you have several ingredients you will mix together, and you want to know the relations, the ratios of these components, and for that you can use mixture designs. What I will show you here is also that you can use these factorial designs for mixtures. Let's start with these factorial designs. I will give you an example. So in this case, it's a very simple one, but the idea is that you understand the principle of this approach is, for example, you want to find out the temperature, which is the factor A, and the concentration of a component on a quality response, on a quality parameter of this bread. So to plan your experiments, you have to specify what is the quality of your bread. So it could be the volume, could be some mechanical parameters like firmness or elasticity or whatever. And then you have to, for each factor you want to find out, you want to quantify the effect, you have to set two levels, a higher level and a lower level. So in this case, could be an example that you want to find out how the when you increase the temperature from 80 to 90 degrees, how would that affect on the volume, for example, of the bread? Or if you increase the concentration of a component from 1.5 to 2.5%, what would be the effect on this quality parameter? And important is also that you have to keep all the other factors constant, otherwise this is not working. And what is also important is to know the experimental error. That means what is the variability of your measurements that you can decide if a factor is significant or not. So when you have specified this, then you can set up your experiments. So you see, it's very easy. You just need 4 experiments to get a model with which you can describe these relationships between the 2 parameters, the temperature and the concentration of a component. So the first experiment would be you combine factors on a low level. That means you make your bread, for example, with 80 degrees and a concentration of 1.5 percentage of these ingredients. You want to know the effect. The next experiments, you make the bread with 90 degrees and also with the same concentration and on. So with these 4 experiments, you can then find out the effects and also a model. But to check the models, you need also some other experiments if your model can really predict or can describe the reality. So in many cases, you make a center point, you make an experiment in the middle of these parameters, and then you can use these and compare this with the predictions. It's also very easy to extend this to more factors. So there is you just have to double these matrix and add a factor, 4 experiments on the low level of this factor and 4 experiments with high level on this factor. So when you have set up this matrix of experiments, then you carry out these experiments in a randomized order, and then after that you start the evaluation. So you can calculate the effects, which is very easy. You can display this graphically, you can check the significance, you can get the model, but also the model you have to check, and then you can make your interpretation. So on this example, I will show you how you can do that. So you make this matrix of independent factors. So you have factor A, B, and A, and this column with A, B represents the interactions. So you can also calculate a number of these interactions. I will show you later. So you carry out these experiments. This is for 3 factors. Then you put in the results of your product. So one column could be, for example, the volume. Another one could be firmness or the porosity, density, or whatever. And then you can calculate these effects. And this is also very easy. You don't need really a statistical program for this. You can use a spreadsheet to do that. Here are the formulas. You don't need to know them by heart. You can always have a look at these presentations. By the way, this presentation I uploaded already in the handouts, so you can download the PDF of this presentation. But it's very easy also to calculate these effects just by using a spreadsheet. So you have these results here, and you want to know the effects of the variables A and B on this response. So you just multiply this number, the results, with -1 and +1, and then you sum it up, and then you build the difference, the plus values minus the minus values, and then you get the value 35, in this case 35.5. That means if you increase the factor A, maybe which could be the temperature from 80 to 90, that means your maybe volume will increase for about 35 milliliter or cubic centimeter. This is a value, but you have to check if this is significant or if it's in the variability. When you're repeating the experiments, then you have a certain variability. So maybe if you repeat an experiment with the same conditions, you may get a value of less than 35, or the variability is less than 35 or even higher than 35, and with that you can decide if an effect is significant or not. This is the result what you get with a statistical program. This, for example, is we used stat graphics, and I will try to explain now what information you can get out when you use this tool. With just 4 experiments or 5 experiments with the center point, you can get a lot of information. So one is you get a model, or where you can describe the relationship between the variables, the input variables, and the response. And you see in this case there is also an interaction. It's AB. It's also in this case significant, and the numbers what the program is calculating, or what you can also calculate just using a spreadsheet, can be interpreted like this. For example, as for A, you get the value of 1.7. That means if you increase the variable A from the lower level to the higher level, the difference will be 1.7 in this case. And the value of the number B means that if you increase the factor B, maybe the concentrations from the minus level from 0 to 1.5, this increases the this response variable for a value of 0.7. And what you can also see here is the interaction. So you have a value here, but what, how can you interpret that interactions? You can see here when you display this model that, for example, the factor B, so if you increase the concentration, for example, from the lower level to the higher level, there is no effect if you have the other variable on the high level. So there is no effect on this level. But if you are on the lower level of the factor E, then you have a high effect of when you're changing the factor B. So this is the meaning of the interactions. So at high level of factor E, B has no effect, and at the low level, B has a big effect. I mentioned before that it's very important to have an idea about the variability of your experiments, and this depends on many things, and you have to know the value. You can find out this experimental error from many things. You can go to the literature, you can have the standard deviation from previous experiments, you can also calculate from the experimental data. In many cases, it's calculated from additional experiments. For example, if you repeat the center point or you repeat all the experiments, then it can be calculated also from your experiments. Or another is you insert a variable which you know there is no effect, then you can also use this effect then as experimental error. When you have now then decided which factors are experiments with these significant effects, you can also create this model. In this case, just by dividing the number of effects by 2, because in this design we had 2 levels, and then you get a model where you can describe the relationships. So with this model, this area can be described, and then you can pre-calculate for each variable when you select a value, what will be the results in this combination. you should also check the models, because we made a pre-assumption in this case. If we use this linear model, then the model can only describe an area, but the reality is very often nonlinear relationships. So then you have to do some more experiments that you can describe this reality with a nonlinear model. And the easiest way to check the model is that you calculate the model just with these 4 experiments, and then you can do the center point, but you can also then pre-calculate the center point and then just compare these 2 values, and you see if they are equal or not. Then you can decide if the model is adequate or not. Another possibility is to use these simple designs also for mixtures, and this is also very often the questions: what are the effects of when you add components, what concentrations you have to add, and what are they affecting the results? There are programs where you can use mixture experiments, but if you don't have a program, you can also use these factorial designs, because you need nothing else than a spreadsheet, and you can also use these factorial designs for mixture experiments. But you have in mixture experiments, you have some restrictions, and one prerequisite of factorial designs that you must be able to change the variables independently from each other. But if you have a mixture, you have the restrictions that the sum is always 100%. That means if you increase the concentration of A, then you have to decrease the concentration of other components. So it's not possible to use these design for mixtures, just inserting the concentrations of the components. But there is a trick how you can do that. Also, another restrictions could be that the components cannot be varied from 0 to 100%, because you have also a lot of other ingredients. That means you have to set upper and lower limits for that. And there is also a methodology how you can, when you make a matrix with the limits, that you can calculate the center point. But the trick how that you can use these type of tools also for mixture experiments, that you make the variables are not the ingredients as concentrations, but you use ratios. For example, you use the ratios, you relate every component to another component. In the cereal or for breads, for example, it's very often used that you relate everything to the flour component. So if you want to add, for example, these arabonic silanes, then you relate these to the flour. So you make these relations, and then you can use these relations as variables. I don't go in detail how you can calculate this, but it's also very easy to set up then these relations and the matrix. And from this matrix, then you have to recalculate the real concentrations of the components A and P. This can be done with this formula. Then you also get these recipes where you can carry out the experiments, and then you can also interpret this in the same way as I told before. So to summarize this now is, again, you can use this tool to identify which factors are significant. Then you can also quantify the effect, not only of the main effects, but also you can quantify the interactions, which is very often the case in these mixture experiments or in the research of bread. And also you can find out which factors are the best combinations for your purpose. So there are many advantages when you use this tool. You will have less experiments. You will get the model where you can this can be used for pre-calculation of your response. You get information of interactions with other tools. You don't get this information, and what is also very useful is to find out the best conditions for to get the same results. For example, if you want to add a component maybe which is very costly, then you can get the same result, maybe the volume, if you work at a higher level of component A and a low level of component B. And you get the same result if you work at the low level of component A and the high level of B. So for example, if B is very costly, then of course you will choose these combinations where you have low level of component B and high level of component A to get the same results. So with this, I'm at the end now, and I would like to ask you for your questions regarding to this presentation, or what experiments you have in mind for your experiments. So thank you very much.
Thank you, Gerhard. That was very, very useful. I wish I knew about this tool when I was a student doing tons of experiments. It's very useful to see this modeling tool. So we go back to our students and ask you to raise your hand, and we will open your microphone. And I just point out to Maria Francisca that I made you a panelist when you were asking question before, so you can open your microphone yourself, Maria, and if you have a question for Gerhard. So the floor is for the students.
Maybe the team of Adlai, because they raised these questions, they maybe have something in mind how they want to use that.
That is the team. Which team was that, Gerhard? Mikai?
No, Adlai.
Adlai. Okay, let me see who we have from this team. Team Adlai. Okay.
Because one objective of this competition is also that we work together. So if you have for your results, maybe you have something in mind, and I could help also to how you can apply this methodology.
I see there is no.
There is a question now.
Oh yes, we have one question now.
Great.
From Tusha. I'll open your microphone. You can ask. Tusha, you can ask your question. Okay, maybe it's not a direct question. He just says very useful presentation. Okay. As most of us would starting our master's thesis soon. So
yeah. So if you, I know that maybe it's we don't have enough time now, and also it was very brief introduction, and the details always depends on your situation. So if you want to use these, you can also contact me afterwards, and I could try to answer your questions if you like.
Yeah, you may get contact from Team Adlai because I see that they are not here in this webinar. So when they see the recording, you may have some contact from them. Okay. Okay. Okay, so thank you. And we move to our next presentation, and I see the time is short. So I ask our next two presenters to please try and stay concise. And our next presenter is Vish Prakash. And Vish is a professor in the university in Bangalore, India, the Ramaya University. And he is also the founder and the chairman of IFRI-FANS, which is a not-profit organization on food and nutrition security for health and wellness. And Vish will talk today about buy and co-products value addition in the cereal chain, with a focus on nutrients and bioactives inclusive of novel processing. So with that, I turn the floor to Vish.
Thank you, Catherine, and it's a great pleasure for me to join this group. And the Food Factory for us with the student suggestion webinar is very unique, I feel. I don't have too many slides because I thought it's better to give some points to the entire group and participants. You already heard about gluten and bread by Dennis and how cellulose, hemicelluloses in cereals play a major role. Gerard gave us all the tricks of experimental modeling, design, quantification, multiple factors to be identified. What I will do is to take you through the co-products and byproducts of cereals that really makes a lot of difference in value addition with novel processing, including artificial intelligence today, to come into food technology. And after me, there is a talk on cereals and nutrition and its benefits, so I'm not going to touch upon that. So let me focus on the co-products and byproducts and the technology for ensuring a holistic approach of cereals. But before that, it is very important to use one terminology for cereals in general, because this has led to a lot of confusion in the global arena, both in the academia, research, policy matters, government, and also industries, that cereal grains are many times mentioned as ancient grains, modern grains, GM grains, orphan grains, etc. But whatever is the point, they are basically nutri-grains, and that we should not forget. So when we look at processing of cereals, and we look at every cereal, be it be wheat, be it be paddy for rice, or even millets and legumes and pulses, and even soya bean, has number one, carbohydrates in it. Number two, proteins in it. Number three, lipids in it. And number four, as Dennis correctly mentioned, cellulose and hemicelluloses, and many other ingredients, and not just these 5 ingredients. It has a lot of amino acids, lot of peptides, and a lot of small sugars, and it's a rich basket of many goody things. So therefore, when you bite a piece of bread, or when you bite a piece of kisra in Sudan, or you bite a chapati or a roti from wheat in other countries, what you are biting is all these put together. So when we look at value addition and technology, because Food Factory and technology are related, just I will take you through the basic constituents of all these cereals, which contains an endosperm, which is the largest portion, the germ, which actually becomes a plant when you put it in the ground. It will be a very small amount, and the bran, which covers it, not the husk we are talking. The bran is a layer on the wheat or even on rice. It's a small layer, and then comes the husk on that. So therefore, when we look at any cereal processing, we need to focus at what level we are. Normally, the husk is removed in the primary processing, and the secondary processing removes the bran, the next layer on these cereals. And the third layer will be to peel the cereals layer by layer. For example, when we talk of wheat, we need to peel 16 layers of wheat and get different products for different end users. So it is not powdering a grain, it is peeling the grain. So therefore the technology is very sophisticated. It is not just grinding, and that is the whole flour, but it is peeling the layer by layer and getting enriched gluten and then processing in the tertiary sector where Dennis mentioned about gluten. You need to take that flour, which is rich in gluten, wash off carbohydrates with lots of water. And today the technology has changed. We even use air for doing it, and then when we do all this, we get a small portion of endosperm. That is a small cuticle which becomes a plant when you plant that seed. Normally, for 1 ton of wheat, we get 1 kilogram of the endosperm. So the yield is very less, but the value is very high. So when we talk about rice, we talk about these byproducts and co-products. Rice gives us the bran and the endosperm. And from the bran, we get rice bran oil, which is the only oil used in Japan. And its health benefits are well known to longevity, to reduce the cholesterol, and take the lipid profile to a level. Similarly, when we look at the wheat industry, which we are talking very, very close with many products around the world, not only bread, but many, many products. There are about 385 products known in the modern world. But I think it is more than that because each food is being added. Sometimes an ingredient is wheat to build the property. So therefore, when we process wheat, we also get different fractions. And that is the modern mill, which peels the wheat and gives us enriched fractions. And in that, when we look at the final output, the wheat germ, which is the wheat germ oil, is the richest source of vitamin E. So many a time, many industries run for getting that vitamin E rich oil rather than the wheat flour. Actually, the wheat flour becomes a byproduct because the cost of the wheat germ oil is very high. Similarly, when we look at millets and legumes, each one of them have a combination of these carbohydrates, proteins, lipids, and cellulose and hemicelluloses. In terms of role, the carbohydrates are not to be neglected, and only take the protein is not the slogan today. The carbohydrates are required for your microbes and the gut in the stomach and the intestine. So therefore, products today are recharged from the refined flours to pull back and add the carbohydrates and make sure that the gut is healthy in the stomach, and therefore the entire process of absorption is very different. Similarly, protein quality and balance of amino acid, we add external combination of multi-grains, multi-cereals today to compensate. That's a high tech, and we use what is called intolators. And these add the defined amount of flours of different cereals into a product by artificial intelligence of how it is flowing through the chute, and it is added automatically, almost like a juice maker. Either it is a carbonated beverage or an orange juice, you get it from the tap. So it automatically operates in the mill to get you the balanced quality of proteins and the balanced quantity of carbohydrate. Except soybean and flaxseed, most of them, we don't look at lipids as an important factor. However, it is the most important when it comes to development of brain because many of them have very high level of very important fatty acids like omega-3 and omega-6, which we don't get otherwise in a vegetarian diet. So therefore, compared to all these, when we talk of cellulose and hemicellulose, it also takes away saturated fats and cholesterol and low density lipoprotein. And today we have a mechanism to make granules which are released at different point of time in the day by coating. And these coated hemicelluloses and celluloses liberate at different times to take away the way we reduce the cholesterol and low density lipoprotein. It almost mimics the effect of statins, which is today given for reducing cholesterol. Therefore, dear students and the groups and participants, the entire role of cereals is not just one single role, but as you can see, there are nearly from paddy and rice, we almost can get alpha tocopherol, tocotrienol, vitamin E, and at the same time vitamin A and fatty acids, and at the same time the rice bran proteins, and most importantly the rice bran oil. And therefore the byproducts looks like the real situation of innovation for you. And this is where tomorrow's world of food factory depends upon its value addition. Even in the business of non-cereal products, today cereals are entering and making a revolution because of their health and that it gives to the body, but at the same time, small molecules which matters a lot, which otherwise we don't get from many other foods. Therefore, the co-products and byproducts of cereals is very, very vital, and we shouldn't neglect it and look at only the cereal powder as one ingredient. As a matter of fact, it's a multi-ingredient, and therefore it is vital for us to focus on this aspect in terms of new innovation, in terms of food engineering aspects, also in terms of value addition to multiple products by innovating the innovation. Thank you very much for your concentration and focus, and I will be very happy to answer any question. Thank you.
Thank you very much, Prakash, for that very interesting and relevant discussion. Thanks very much. So we invite the students to comment or perhaps have a question for Prakash. We will take a few minutes.
Yes, we have one from Maria.
Mm-hmm.
Go ahead, Maria.
Hello.
Mm-hmm.
Hello.
Yes. Good morning. Thank you very much for your presentation. My question is, as considering that using byproducts from grains and cereals is a very important aspect, could be also maybe better to use a whole grain, like the whole grain or whole cereal, to use to create innovative food products, not separating in parts, but using like the whole grain itself, and giving an added value in the nutritional part and also in a supply chain, and maybe also like innovative part, disruptive concept.
Yeah, it's a good point. It's a good point because in terms of the various ingredients we're looking, I'm getting an echo, and that okay? Are you able to hear? Okay,
It's better now.
Great. Yeah. So basically, it's good. But suppose I use a whole wheat flour for the bread. I need much more ingredients to make it rice, and therefore, many a times the end product demand will what decide whether we need the whole flour or a fractionated flour. For example, in the rice, if we don't remove the bran, it takes 1 hour to cook rice. If I remove bran, I can cook it in just about 15 minutes. And also, if I don't remove the bran, the shelf stability of rice is only 1 week. It contains lipase 1 and lipase 2. So the rice gets rancid in 1 week. So keeping quality of rice to keep it for 6 months, the rice is polished. So therefore, many times the processes and the innovative things that we do for cereal is not only for the benefit of nutrition, but also for the public distribution. I cannot make a wheat flour with a lot of wheat germ oil in it because it goes rancid. And therefore, my wheat flour shelf life is very less. So in turn, my bread becomes stale much earlier. So therefore, it is a balancing of the total flour and the refined flour. But these are not to be termed as refined flour, but to remove those that will reduce the shelf life is the main point. So therefore, you will have white rice if you want to keep rice for 3 months, 6 months. But that's the way it is. If you have red rice, unpolished rice, you can keep it for 1 week. Then it's not possible for the factories to produce in large quantities, export rice to many countries and so on. So it's a holistic approach of the global trade and the nutrition and everything inclusive of not wasting any single product. For example, the rice husk that we are talking, in India, we make furniture out of it. Not even one rice husk is wasted. Everything goes to making furniture. So this is how we need to reduce the carbon footprint of everything. And therefore, it is very vital to look at what is the consumer demand and what is healthy, and use the remaining portion for making better profit, not only for the factory, but also profit of job orientation and carbon footprint minimization. Thank you. Thank you, Maria, for that question.
Thank you very much.
Thank you. Okay, thank you, Prakash. And I think we will move on as we are going over our time, and we have one final short presentation. And this is on the Nutrigrains cereals and richness of traditional foods with it. And our presenter is Jamuna Prakash. And Jamuna is a retired professor in the Department of Food Science and Nutrition at the University of Mysore in India. And Jamuna, I will hand the floor to you now. Jamuna, can you test your microphone?
We see your screen, but yeah.
Excellent, great. Okay.
Please go ahead. We cannot hear you.
Now your microphone is off. You have to turn your microphone on, Jamuna. Do you see to turn your microphone on? There is a ground green icon that is a microphone. In your case, it is red. You have to press on that to have your microphone go on.
It's on the control panel of GoToWebinar. Yeah, now it's on, but we still cannot hear you.
Mm-hmm.
Do you maybe have a headset you could plug in?
Okay, why don't we show our technical points to the students, our practical points, while we see if Jamuna can get her sound on. Okay, Line?
Okay, then
What do you think?
I'll make you presenter again.
Yeah, okay. Okay, so we just shortly want to remind the students that when the webinar is over, you get a survey about this webinar, and please, we ask you to reply to this survey because this really helps us to improve these competitions. Oops. And we need your input. Your input is crucial. So please reply to the survey. And also you know that as always, the recording will be available so you can go back and look more closely at the webinar that we had today. And finally, Lena and I want to remind you about what is coming up in the Sustainable Cereals competition. So the week of 27 January, we have our project review meetings, and 10 of the 14 teams have signed up for a 30-minute spot. And I don't remember who the 4 teams are that did not sign up, but you know. So if you did not sign up for your project review, please do that. We ask you to come to the project review with a draft of your presentation, a draft of your project. So a couple of slides, not finished at all, and we will talk about it with you. We want to hear what your project is about. And then in the week of 11 February, on the day of 11 February at 1 o'clock European time, we will have the soft skills webinar. And this will be a real opportunity for you to polish your presentation skills, your speaking skills. And then the 15th of February is in red. This is the day when your project presentation and your report must be submitted. So your slides should be either a PowerPoint or a PDF, and your written report of 4 pages should be sent to the email that you see here on the screen. And the template for the written report is available on our competition website, so you can have a look there. And then on the 6th of March is our actual conference. Now this virtual conference is being advertised far and wide in the ISEKI newsletter, going to 8,000 subscribers, and through all of the Next Food project partners and through our sponsors, the ICC and the AHDB. So there will be probably a very good attendance at this conference. So we are asking you to have a polished presentation for the 6th March conference. And you see that the time is quite long, from 12:30 until 1600 European time, because we have 14 teams presenting. I believe it is 20 minutes, but the timing will be quite strict. So be sure to practice your presentation and have your timing as it should be. And at this virtual conference, we will announce the winning team. And the winning team has the fabulous prizes of free registration and guaranteed speaking slot at the Whole Grain Conference in Rome, cash prizes, free ISEKI-Food membership for 1 year for all the students, winning certificate to hang in your office and put on your curriculum, etc. So we're really looking forward to this conference and to having the winning team announced. Okay, that is it for Lene and I, and if there are any questions from the students now about the practicalities of our competition, we can go ahead and take those. I see something written. Do you see something, Lene?
Yeah, that was from Jamuna. She has now a headset, so we'll see if it
okay.
works.
Okay,
Can
great.
you hear me now?
Yes, we can. Okay,
Oh,
so
okay, that's great.
the students, you are welcome to write any questions you might have for me and Lene about the practicalities of the competition in this chat box or to us by email. And we will continue now with our student suggestion webinar and go on to Jamuna for her presentation. Okay.
Yes,
Thank
so
you.
Jamuna, I will
Thank
make you presenter, then you can share your screen again. I think we can hear you now.
Mm-hmm.
Yes. Can you see me now?
Yes, we can see you and hear you.
Yes. Okay.
Yes.
Okay. Okay. So thanks for inviting me to be a part of this session. I was informed pretty late, maybe around 2:30. So right now I don't have any presentation ready as such, but I can definitely talk on nutri-grains. So the topic given to me was nutri-grain cereals and richness of traditional foods. Now to start with, I think I have to say that all grains are nutri-grains because any cereal grain you take or millet you take definitely provides you all of the part of carbohydrates, proteins, vitamins, minerals, and fiber. And we also now know of many bioactive components. But all these are present in the whole grain. I just heard in the previous session, a student asked a question about utilizing whole grain. So that's very true that when I talk about the traditional nutri-grains, these were always used as whole grain. We have examples of different kinds of grain processing method in different ethnic regions, but we know that most of the time it was in the whole form which was used. And for that, what I generally advise is that as much as possible, use the grain in the form the nature has given you, in the natural form, to get all the benefit of the grain. Now I have few points to talk about the traditional use of grain and its richness. Traditionally, the grains were used either as cooked in the whole form, as we had rice, or they were milled or converted into flour, and they were used in different kinds of preparations like either flatbreads or leavened breads. The use of flatbreads has been very common in Southeast Asian countries and whereas we have bread, the leavened product, mostly in European and the Western countries. Now, we also followed, traditionally, these countries also followed fermentation as one of the technology. And now we know that fermentation itself changes the grain into a very, very healthy product. And these were the auto fermentations which were tried and the auto fermented batter or the dough that was used for making the flatbreads or the pancake kind of products. The next point to discuss about nutri-grain is that many times form the staple of diet in combination with many other ingredients, be it either a grain like legumes or vegetables or spices. Now these added extra nutrients apart from giving the sensory quality to the product which was prepared. There's one unique part of the sensory quality of the grain. They are generally bland in nature, so they blend well with any kind of ingredients you use, and they also cater to the sensory need of whether it's an infant or an elderly person. Throughout the life, you can convert the cereal grains into some kind of product which is suitable for any kind of population. Coming to the cooking methods of the grain, traditionally the roasting, steaming, boiling, baking, these are all the various used at the household level, and now even at the commercial level we have all these being used. And the nutritional quality of any of the product which are prepared, it depends upon the kind of cooking method used for preparing the product. For example, in case it is a dry food matrix, like when you roast a product or bake a product, it is mostly a dry matrix. Now in a dry matrix, the nutrient availability goes down. But in case you have a wet matrix like a gelatinized flour, like a porridge, then the availability of nutrients goes up. So this was like made according to the need of the population. For an infant, a porridge would be prepared because it's easy to feed and you want the infant to absorb more nutrient. But if it is an adult, then we can always have a pancake kind of product, a steam product, or a dry product also, since an adult body is able to utilize the nutrient inherent in all these. Apart from the regular nutrients, which were mentioned before also, some of the grains also have some anti-nutrients which bind with nutrient, make it unavailable. For example, wheat flour is very rich in phytic acid. The finger millet, one small black colored millet which is used in Southeast Asian countries and in African countries, that has again a high content of phytic acid. Now these can bind minerals, but by using different kinds of cooking methods, for example, fermentation or germination, malting, the amount of these anti-nutrients can be brought down in these grains, and these were used traditionally at household level. Now, I also want to add a point cereal grain, because being rich in carbohydrates is generally high, but especially if it is a product based on the refined flour. Once we use a whole grain product which is rich in fiber, then automatically the glycemic index comes down. There is one more point, that traditionally, at least in our part of the country, for infant food, we used sprouted or germinated grain. Now, once we sprout or germinate the grain, it is very rich in enzymes, and this can take care of the viscosity of the product which is prepared. Because for an infant, we need a nutrient-dense product. So we can use a higher amount of flour, but the energy density is going to be high, and this is going to give more nutrition to the small child. So these are all the technologies which can be used at household level, and these were being used traditionally. Then something about the bioactive components of these whole grains. We know that as long as you are using it along with the outer layer or the fiber, the content of all these, whether it's condensed tannins or other bioactive principles, all these are very high. Once we refine the grains, it goes down. And now the research has also shown us that most of the time, these bioactive principles, they are available to the body after digestion. So when we want to estimate the grain outside the laboratory, as we have done it many times, we do not find the content to be that high. But once it undergoes a process, like you use human intestinal digestion enzymes, you find that the amount of these bioactive principles like condensed tannins becomes very high. And that is because in all these grains, the bioactive principles, they are bound to the fiber fraction of the grain. And once it goes inside the body, through the process of digestion, these are released and they are made available to the body. So essentially to tell you that grains in the whole form are very nutritious, they form a major part of the meal, and once if it is processed, then even in the processed form, it is good, provided as much as possible, the whole form of the grain is retained. So this is my presentation on the nutrition of the traditional products made from whole grain and how these were used. If you have any questions, I can answer.
Thank you very much. That was really very, very interesting. Thank you also for your perseverance to get connected. That was great. Okay, the students, we know we are running a bit late, but we will take a couple of minutes. If there are any questions for Jamuna or any comments, please go ahead. Oh, I see there are still many students on the connected on the webinar. Maria has a question. Maria?
Hello?
Okay, yes.
Can you hear me?
Yes.
Thank you very much for your presentation. My question is, how do you see the possibility to combine different technological aspects? For example, if fermentation is mostly used for watery, like liquid preparations, how do you see the possibility to combine fermentation and after applying some technology to make a dry product?
Okay, it should be possible. See, because for fermentation, we need some amount of moisture for the yeast to grow, or even the natural fermenting organism to grow. Because unless moisture is present, this fermentation will not take place, since moisture is needed for the organism to grow. So after the dough is fermented, initially itself, we can control the amount of moisture in the dough as we do in the bread dough and ferment it, and then later on it has to go through a process of drying. This will be a long process of dehydration, a slow dehydration, maybe in an oven. So if you just allow it to dehydrate and let the moisture out, you can still have a fermented but a drier product. For example, you can have a drier cookie or a drier biscuit made out of fermented flour, but as I said, this will need a longer time of dehydration. So we have to use some instrument to make it dry.
Thank you. And regarding the nutritional impact of an drying process, would it be still good for the product?
Okay, yeah. See, drying process, if you use a higher temperature, then there is a nutrient loss. But when you see in baking, the temperatures go up as high as 180 to 200 degrees centigrade. But in drying process, we use much lower temperature than that. One more point is that the benefits of fermentation, whatever there are, see, especially it increases the digestibility of starch and protein by breaking it down. these benefits are going to remain even after you dry the product. The only loss can be a bit of small amount, not even total, small amount of some B complex vitamins which are not stabilized by heat, which are heat labile. And these only get destroyed at high temperature, not at lower temperature.
Thank you very much.
Actually, I do not see a major nutrient after fermentation when the product is dehydrated.
Perfect. Thank you very much. It's very clear.
Then we have another
Thank
question
you.
from Maria Francisca. You can open your own microphone.
Yes.
Hello, Jamuna. I would like to ask about
Yes.
the traditional food that you mentioned before. In a household level, you said before that usually
Yes.
people in your region could use the whole grain using fermentation to make
Yes.
their own food.
Yes.
Can you explain more about the example of the traditional food? And
Yes.
how about the storage condition of the final product? Do we need refrigerator or not?
No. See, there is one particular region in India, they are still using whole wheat flour. Okay, the wheat is milled, not a part of wheat is taken off. The whole wheat flour is mixed into a dough. It's a tight dough, and it's just allowed to rest. And it's allowed to rest overnight, maybe for about 12 hours, 16 hours. And there is auto fermentation taking place in the flour. And after that, it is converted to a flat bread by baking it on a indigenous stove. Okay, it's like a flat iron pan on which these are baked. Okay, so this is a fermented product, and also when it is cooked, it is actually roasted. So when it is roasted, it becomes fairly dry, and this is stable even for a whole week. So they can store it for a whole week also. This product just does not get spoiled. It does not need any refrigeration. So this is one example of auto fermentation of a drier product done at home. It is possible.
But when you do auto fermentation, can you control the final product? Will it be different from day to day?
See, it will, because we are used to this auto fermentation. I think the degree of sourness is something we control by allowing it to ferment for a certain known number of hours. Like what we do is, there is a pancake kind of product which is fermented and made in South India. In summer months, we ferment it only for 10 hours. Because the temperature is very high, the fermentation is, takes place at a higher rate. In winter months, we ferment it for much longer hour because we want the degree of sourness in the product. So we control it by hours of fermentation, which can be done easily by experience, not an issue. And the product is all going to the quality of end product is going to be similar. We can control it very well. There is no problem.
But the microbes that it include in the process, you usually.
This is natural fermentation. This is auto fermentation is natural. So we are not introducing anything from outside. It just happens because of the natural substrate of the grain itself.
Okay. Okay. Thank you. Condition. Thank you.
Thank you.
Do you see anyone else, Lina?
I think that's it.
Yeah, me too.
Yeah.
Okay. Okay.
Okay.
Good.
Thank you very much, Jamuna.
Thank you very much.
Thank you to all of our speakers, Gerhard and Vish and Denise, and to all of our students, especially to those who had questions and comments. We really appreciate you. So have a good rest of the day, and we will see you all at our next Sustainable Cereals Food Factory for Us webinar. Okay. Bye.
Great.
Bye.
Bye.